in triangles, there's 4 special lines which are called concurrent lines. And in them, they have unique properties that we can do things to the triangle. So in this case, concurrent is a word that means when 3 or more lines intersect in one point. So there's 4 types of concurrent lines, and from each of the vertices of the triangle, they will intersect somewhere in or around the triangle and have some special properties. This intersection is called the point of concurrency. So here's an example of a perpendicular bisector. So the first concurrent line is called perpendicular bisector. And so if you remember, a perpendicular bisector is going to take a side of the triangle and bisect it perpendicularly. So in this case, this triangle would be bisected at a 90-degree angle, and that means that this section and this section of the side are congruent. In this triangle, this is a right triangle, we're going to bisect it here. So notice the difference between perpendicular bisectors and the triangles. This one goes pretty close to the vertice, this one doesn't. This bisector, again, is going to split this side in half, and it's going to be far away. So again, perpendicular bisector, we have to go back to Unit 1 where we talked about these definitions. It takes a side, it cuts it in half at a right angle. All right, now if we were to do this with a second side, for example, in this, right? So if we take this side and cut it in half perpendicularly, they're going to intersect, and that intersection is called the point of concurrency. This point, we're going to talk about some special properties that occur when this happens. All right, so the circumcenter of a triangle, okay, so now we have our new word here, circumcenter. Circum means it goes around the center. The point of concurrency of perpendicular bisectors. So perpendicular bisectors that intersect create a circumcenter. Using this, we can circumscribe about a triangle. So here's an example of that. If we have a triangle and we were to connect 3 perpendicular bisectors, that would create this point. From this point to the vertice of a triangle, that would create a radius of a circle. And if you were to draw this, the circle would touch the other 2 vertices exactly, allowing us to draw a triangle. Okay, so what happens here is the perpendicular bisectors are concurrent. Okay, so they intersect at a point that is equidistant from the vertices of the triangle. Okay, so this point of intersection is going to be the same distance to each of the vertices of the triangle. All right, so here's a question that comes up quite often in tests, quizzes, and exams. If we plot these 3 points, we're going to have a triangle that looks like this, and this is a right triangle. So if we want to split this in half, right, perpendicularly, we're going to draw a line here. So this is 2 and this is 2. If we want to split this side in half, this would be 3 and 3. So that's our point of concurrency, right? If we go back, that point of concurrency again is called the circumcenter, right? And that circumcenter by definition says that this distance to here, here, and here are all equidistant. So we could draw a circle around it with the compass. In this case, if we graph these, we would have another right triangle. So in this example, if we perpendicularly bisect it, this would be 2.5 units, and this is 2.5 units, right? And then if we come down here, this would be 3 and 3. And so there's our point of concurrency, the circumcenter. And the circumcenter says this point is equidistant to all 3 vertices, allowing us to draw a circle and touch each of the vertices exactly on the vertices. All right, the next one we're going to talk about in this video is angle bisector. So angle bisector, remember, if we were constructing it, would look something like this. And what it does is it's a line that splits an angle into 2 equal congruent portions. So in this example, an angle bisector might look like this. In this example, the angle bisector is going to have more angle to it to the opposite side. And in this case, it's going to have even more angle to it. Now the angle bisector is only dealing with the angle. It doesn't do anything on the opposite side. It only splits the angle in half, so keep that in mind. The perpendicular bisector is going to split the line in half perpendicularly. The angle bisector is going to cut an angle in half, right? So when we have intersecting angle bisectors, this is called the incenter. So the other example allowed us to draw a circle around a triangle. This is going to allow us to draw a circle inside the triangle, intersecting the circle exactly at one point. And that point is going to be from the incenter perpendicular to the side of the triangle. So if you were to go from the side of the triangle perpendicular to the incenter, that would be our radius of the circle which we can then create our circle. Okay. So comparing circumcenter and incenter, the incenter is going to be equidistant. So all of these distances here in the diagram are the radius of the circle. So this distance is equidistant to the side perpendicularly.